Okay, now we're going to look at number 12. Okay, so first we're going to read the problem. Again, what you want to do is you want to kind of chunk the problem, and as you're reading it, as you get information, write that down. The more you write down on paper, the less likely you are to make a mistake. The more you write down, you can help visualize. So we're going to write our given. It says a 65 kilogram crate, so mass is equal to 65 kilograms, is to be accelerated at 7 meters per second squared up. So the acceleration is 7 meters per second squared, and I'm going to write up because that's going to help me for my free body diagram. An incline making an angle of 25 degrees with the horizontal. If the coefficient of friction between the crate and the incline is 0.2, how much force is required? So they want to know how much force is required to pull it up, so we're looking for FA, the applied force. So the first thing we're going to do is we're going to draw our free body diagram. I need to establish my sign convention. So the first thing I'm going to say to myself is, which way is the block moving? It's moving up the incline. So I'm going to make up moving just so I know. Why is this important? Because the movement has to be with my sign convention. So my sign convention is up and to the right is going to be positive, but it's going to be up the incline. So now I draw my object. Now, the block is moving up. We want to find the applied force. The applied force is going to be pulling it up, pulling or pushing. So this is the way my applied force goes. And this one is parallel to the surfaces in contact. Now, when you take higher level physics courses, are you going to have forces that are not going to go parallel and perpendicular? Yes. When you get to centripetal force, not in high school physics, but in college physics, what happens is when you have a centripetal force acting on an object, that would be like a car on an embankment. Like, you know, when we get off the highway on Indiantown Road and you're going around a curve, that curve is actually banked. And what happens is you also have centripetal forces acting on the car. You actually don't sum forces perpendicular and parallel. You sum forces in the direction of the centripetal force, which acts towards the center. But that's something that you're going to do in college physics. Okay, so I just want to let you know, you don't always do things perpendicular and parallel when there's centripetal forces involved. Luckily, we don't do that in here. Okay, but that's something you're going to do when you get to college. All right, the frictional force always acts in the direction opposite of the motion, and it acts parallel to the surfaces in contact. And remember, these are the surfaces in contact. My normal force always acts perpendicular to the surfaces in contact, and my force of weight always acts straight down. And they told me this angle is 25 degrees. So now I look at my free body diagram and I say, which forces are going perpendicular and parallel? All of them except my weight. So what I'm going to do is I'm going to first calculate my weight to the side, and I'll say F of G is equal to mg. So it's equal to 65 kilograms times 9.8 meters per second squared. So F of G is equal to 637 newtons. Now remember, I don't have to put negative 9.8 in here because I'm showing, according to my sound convention, that down is negative. I've already shown it here with my arrow. And then when I sum the forces, remember I make things that are down negative and things that are up positive. So now I would draw this to the side. This is F of G. Now on this, just to help me, when I want to find the components of this, the components have to go perpendicular and parallel. So first I'm going to draw one like this, going perpendicular. From the head of this vector, I do the tail of the other. So these two are going to replace FG, and this would be FGY, and this one would be FGX. But that's kind of messy, so I'm going to do it to the side like this. Remember, these two forces act perpendicular, so there's my 90-degree angle. Here's my right triangle. Because this is perpendicular to this, and this one is parallel to this, these are similar triangles. Here's my 90-degree angle, and here's my 25-degree angle. If I want it to look like this, I'm going to flip it over like this. There now is my 90-degree angle. And here is this angle, which is that one. So that's why this angle here is similar to that one. So here's my 25-degree angle. So this is FGX, and this is FGY. Now what is very important is these little arrows showing the directions of these components. This is where I start, this is where I end up. So this one's perpendicular from the head of this one, I do the tail of the other. So showing these directions is important. All right, so let's calculate this. So FGY, this is adjacent to the angle. So it's going to be FG, adjacent's going to be cosine. So FGY is equal to F of G, 637, times the cosine of 25. So FGY is equal to 577. This is why we don't memorize like X is cosine and Y is sine, because it depends on where the angle is. You cannot memorize that. You cannot memorize like X is cosine and sine is and Y is sine, because it's not always going to be that. It depends where the angle is given, and that's one of the mistakes people were making. Then I find FGX. So FGX is equal to FGX. See how this is now opposite the angle? So that's sine. So FGX is equal to FG times sine of 25 degrees. So FGX is equal to FG, which is 637 times the sine of 25 degrees. So FGX ends up being equal to 269. Once I find my components, and there can be more than one force, then I go back and I redraw my free body diagram. So now we're going to go back up, and I'll just do it right here to the side so we can actually compare them side by side. So remember, I still have my sign convention. Up is positive. I'm going to redraw everything the same. You know, my applied force is going up the incline. My frictional force is going in the direction opposite motion, and it's parallel to the surfaces in contact. My normal force is perpendicular, and instead of F of G, I'm going to replace it with FGY and then FGX. And after I do that, again, I'm going to remind myself of my sign convention. So when I sum forces, I'm summing them in the right direction. So where do I start? Well, if you're not sure what to do, you can go to the end, and that'll tell you what to do. But we know that in these types of problems, we're going to do three things. We're going to sum forces vertically, we're going to sum forces horizontally, and we're going to use the mu equation. Mu is equal to F of F over F of N. Is it necessarily in that order? No. So, where should we start? If we don't know where to start, we go to the end. We want to stop for FA. FA is in the X direction. Remember, this is X and this is Y. So, if I sum forces in the X direction, summation of F of X is equal to MA Is this block accelerating in the x direction? Yes, they gave us the acceleration. So that's not 0, that's MA. Then I replace this with all my forces going in the x direction. So now I look at my free body diagram. What's positive? Well, FA is positive, FF is negative, and FGS is negative. And that's equal to MA. So I have a lot of variables there. Do I have M? Yes. Do I have A? Yes. Do I have FA? No, that's what I want to find. Do I have FF? No. Do I have FGX? Yes. So if I wanted to solve for FA, I still need to find FF. You see what I mean? So there's something else I need to do. So now we'll go on. I'll sum forces vertically. I'll say summation of F of Y is equal to MA. Is this block accelerating in the Y direction? No, it's not even moving. So this is 0. Now I'm going to replace this with all the forces going in the Y direction. So Fn is positive, FGY is negative, and that's equal to 0. So F of n is equal to FGY, so F of n is equal to 577. It is accelerating up the incline, not perpendicular to the surfaces in contact. This is my Y direction. This direction here, this is my Y, this is my X. So it's not even moving in what I'm calling the Y direction, which is perpendicular to the surfaces in contact. The only other thing to do is the mu equation. So mu is equal to F of F over F of n. F of F is equal to mu times F of n. So F of F is equal to 0.2 times 577. So F of F comes out to be 115. So now I just found F of F. So now when I go back to this equation, I only have one unknown, which is what I want to find, FA. Now instead of just plugging numbers in, because when I plug numbers in, that's how I make a mistake. I use basic algebra. I rearrange the equation to solve for the unknown in terms of the known. So because FA is my unknown, what I want to find, is it in the numerator? Yes. Is it on one side of the equal sign and positive? Yes. So I'm leaving that alone. I'm going to leave the FA where it is, and I'm going to move everything else to the other side. So I'm going to leave the MA, the FF I'm going to put on the other side, so it's going to be plus FF, and then I'm going to put the FGX on the other side, so that's going to be plus FGX. So FA is equal to MA, which is 65 kilograms, times the acceleration, 7 meters per second squared, plus FF, which is 115, plus FGX, which is 269. So I add it all up, FA comes out to be 839 newtons. This seems like a lot of steps, but all the problems, if you just follow the steps, and you, again, write your given. Draw your free body diagram showing all the forces acting in the direction in which they act. Then you look and you say which forces are not going perpendicular and parallel. So in this case it was the weight. Then you do the components of that. You draw a new free body diagram showing all my forces going perpendicular and parallel. There's 3 things I'm going to do in every single problem. If you're not sure what to do, you go to the end. So even when I went to the end and I solved for the applied force, I thought, oh, I can't do this because I need F of F. So then you go back and you do something else. So then I sum forces vertically. I found the normal force. I ended up using the mu equation. Mu is F of F over F of n. I was able to find FF, and then I went back and I substituted in. So you're not doing these 3 things in any particular order, and if you do them out of order, then you go and you do something else and you come back to it. But if you notice, every single problem, the picture is different. This is what in your book, in too many high school books, they come up with this and they say working equation. But what they do is they're just like, here's the working equation, and they act like it's magic. They don't explain that I'm summing forces in a particular direction to come up with this. You can't memorize this because this is going to be different for every single problem. So you come up with your own equation based on what's happening in this problem. But if you follow the steps, it's quite simple. And that's it.